Hi, I'm Nathan. Welcome to another edition of Foundation Library. In one of our previous videos, we learned how to use the Query Explain tool to check if a query is optimal or not. In today's video, we'll go through a comprehensive guide on potential fixes for these slow queries. So, we have a flowchart over here that will come in quite handy to troubleshoot and fix these slow queries. Once we have a detected slow query or have a query that we suspect to be slow, we can analyze that using the query explain tool. How to do that? We already learned that in the previous video. So first thing that we need to check is whether that query uses an index or not. If not, then the fix is simple. We need to have an index in the system that can actually serve that query. If the query does use an index, we need to check if that index is being used optimally or not. If it is being used optimally, then we need to check if the result set is very large. If not, then this is not potentially an indexing problem, and we need to explore other causes. There could be problems with the persistence layer or something else, but that needs to be explored. However, if it is indeed a very large result set, then we need to consider pagination. Now, going back to this flowchart, if the index that is being used is not optimally serving the query, then we need to check if there is any other alternative index that can actually serve this query. If yes, then we need to check if that one is optimally serving the query or not. If yes, then we need to analyze why the wrong index is being picked up, because another one which could have served the query optimally is not getting picked up. There could be a couple of reasons for this. First, could be incorrect cost estimation, where the cost of the index that should have been used is somehow coming out to be higher, or somehow the index is not even getting considered by the query planner, or there could be a case where that index is actually inactive or corrupt. If there is an incorrect cost estimation, a quick workaround could be to make the query use that specific index using the index tag options. In case of an active index, that needs to be activated and then reindex. In case of corrupt index, we need to first analyze the root cause for corruption. And once that is fixed, then we need to reindex the index. In either of these cases, such issues should be highlighted to engineering. In case there is any bug in the system, then that needs to be fixed. Now, going back to this flowchart, if there is no other alternative index that can actually serve this query, then we need to check which parts of this query are not served by the index that it's using in the first place. After doing that, we need to check if we can actually change the query in such a way that it still meets the requirements but starts using the index optimally. If yes, then the easiest fix is to actually change the query so that it can start using the index optimally. But if changing the query is not an option, then we would need to modify the index that is getting picked up for this query so that it can optimally serve it. Now we'll run an example query through this flowchart and see how to handle that situation. I have this query over here, select star from NT-base where foo prop 1 is equal to bar ordered by foo prop 1, and it has been highlighted that this query is slow. So now what do? I do an explain. I see that it is indeed using an index. So it's using an index. Now I need to check whether the index is being used optimally or not. I see that it is indeed sending the property restriction to the Lucene query. However, if you notice, the ordering is nowhere to be seen over here. That means the ordering is not being handled by the index. That means that this query is not being optimally served by this index. Is there any other alternative index? So I need to check over here in the logs, and I don't see any other index being considered in the plan. Nor from my developer experience, I know that any other index I have in the system that can actually serve this query. So the answer to this is no. So now I need to analyze the parts of the query that are not being served by the index. In this case, this is the ordering. Now I need to check whether the query can be changed in order to use the index optimally. For that, I need to first check what the index definition is exactly. I can do that using the system console status oak index definition endpoint. I'll search for the index definition. This is foundation libs index, and I can see that it is indexing two properties, foo prop 1, foo prop 2. Foo prop 2 is actually ordered, foo prop 1 is not. So if I can actually change this to foo prop 2 and still have the requirements met, then that can be the case. However, if changing this to foo prop 2 is not an option and I need the ordering by foo prop 1 only, then what I need to do is I need to actually modify this index. So now I have the index definition with me. What I would need to do is I need to add ordered is equal to true on this property. Now, how to actually change the index depends upon what flavor of AEM are you using. If it's 6.5 or it's AEM as a cloud service, in both of these services, changing the index definition is a bit different. Either way, if this is a custom index, we would need to change that in code, either apply that via package in case of 6.5 or via a deployment pipeline in case of AEM as a cloud service. And in case this is an out of the box index, then this needs to be highlighted to the engineering so that they can actually accommodate the changes. This video was supposed to set up base on effective troubleshooting for slow queries. In subsequent videos, we'll run through even more complex examples for more in-depth understanding. Till then, happy searching. Thank you.